Origin's Gage study offers a suite of tools designed to measure error in measurement systems. This video will cover an attribute gauge study, which is conducted to assess repeatability and bias in the measurement system when the attribute gauge provides a binary response, either accept or reject the measurement value. The analysis can be used for single limit measurement system, such as a lower or upper limit, or a double limit measurement system. Origin's input window offers options to conduct the study at the lower or upper limit. Even under a measurement system with a double limit, only one limit needs to be examined. Under the assumptions of linearity and uniformity of error, the shape of the gauge performance curve under the upper limit should be a mirror image of the curve at the lower limit. The requirements needed to conduct the study are at minimum 8 parts with known reference values. The 8 parts are selected so that their reference values are approximately equidistant, with the minimum and maximum values representing the process range. The 8 parts are run through an attribute gauge at least 20 times, and the total number of acceptances, X, for each part are recorded. We will conduct an analysis for an attribute gauge with a lower tolerance limit. There are several conditions for conducting this study. First, the total number of acceptances, X, for the smallest part is 0. For the largest part, this is 20. For the other 6 parts, the total number of acceptances should fall within 1 and 19 inclusive. If the total number of acceptances, X, for the smallest part is not equal to 0, then smaller and smaller parts are evaluated until the total number is 0. The same principle applies to the largest value. If the total number of acceptances for the largest part is not equal to 20, then larger and larger parts are evaluated until the total number is 20. The number of acceptances for the other 6 parts should fall within 1 and 19 inclusive. If these numbers are not met, additional, approximately equidistant measurements should be made throughout this range. Here are the collected acceptance data for parts 1 to 8. Under part numbers, enter part ID. Under reference values, enter reference value. Under summarized counts of acceptances, enter acceptance. The total number of trials is 20. Specify a lower tolerance limit of -0.09. Bias can be evaluated using the AIAG or regression method. To test for bias using the AIAG method, the 8 parts are run through the attribute gauge at least 20 times. For the regression method, the 8 parts are run through the attribute gauge at least 15 times. We will select the AIAG method. Bias is the difference between the reference value and the average of the observed measurements. We conduct a hypothesis test around the bias. Under the null hypothesis, bias equals 0, and under the alternative hypothesis, bias does not equal 0. With a p-value of less than 0.01, there is enough evidence to reject the null and conclude that the bias is significantly different from 0. The probabilities of acceptance are provided in column B under the sheet Gauge attribute. The values are plotted in the normal probability plot under the sheet report worksheet. The best fit regression line can be used to calculate bias and repeatability, which are summarized under the first table. R² is the amount of variation in probabilities of acceptances explained by the model. The higher the value for R², the better the model fits the data. The second plot shows the reference value against the probability of acceptance. The lower limit specified in the input window is the red dashed line. The probability of acceptance at the lower tolerance limit of -0.090 is very high, nearly 100%. We conclude that the attribute gauge should be recalibrated.